Make sure this is on perfect. Alright, okay, so if this example comes from 4B, of course I replaced phi 1 and phi 2 with P and Q. Makes it easier for me to write, but this should be easier. Make sure you can see. Okay, perfect. Now, as you can see, we have not P and not Q, therefore P implies Q. And so in order to prove this, what I went ahead and did was first we're going to assume not P and not Q, due to the fact that we're trying to validate and prove that this is sound. So instead of this being a premise, it's going to be an assumption. So from here, we have the assumption not Q. I can go ahead and make the assumption that we have not Q. This will allow me to open up the implication introduction. Actually, give me 1 second. Let me write that box for you so it's easier for you to see. Okay, there we go. Now with the boxes, you can see what I'm talking about with the assumption and the box that we created here. So if I assume that we don't have Q, we have not Q, I can actually use then the conjunction elimination for line 1 to get not P. And so from here, I have the implication not Q implies not P. And that's with the implication introduction for lines 2 through 3. Now I can open up a new assumption based on this, and I can say that as we're going to assume that I have P. So I'm assuming P on line 5. And from here, I'm actually going to use the double negation introduction to get us not P. And the reason I'm going to do this is because the rule modus tollens, MT, says that in order for us to be able to, if we have A implies B and we don't have B, then we can therefore conclude that we don't have A either. But the only way this is going to work is if I have a not in this situation. So if not Q implies not P, and I have not P, then I can say that we have not Q, if that makes sense. And so this actually gets me not Q using modus tollens MT for lines 4 and 6. And then of course I can use the double negation elimination on line 7 to get just Q on its own. And because this whole box, this whole assumption starts with P and ends with Q, I can say that P implies Q via the implication introduction on lines 5 through 8, and suddenly it's solved. So please let me know if this makes any sense to you. I'm also new to this just like you are, so I'm probably not the best at explaining this, but I hope this is at least able to help you with the rest of the problems. You're still going to need to do the truth table for this to fully to get the completeness, but this is the part I was struggling with. I'm sure this is the part you're struggling with too, so here you go.